Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it again on demand. Following today's webinar, we'll be sending out an email that contains a link for you to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel, submit your question, and we should have enough time near the end of today's webinar to go through the audience questions. And finally, also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around. Hopefully you will be one of our 3 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is From Legos to Transformers, Why Versioning and Configuring Microservices is Critical to Your Kubernetes Success. Our speaker today is no stranger to the DevOps.com webinar scene, Tracy Reagan, who is CEO of DeployHub. Hi, Tracy. How are you today?
I'm doing great. Thank you. Thank you very much for the intro as well.
No problem. I'm going to go ahead and put myself on mute, let you get right to it.
Okay. So I've been in this business of what we now call continuous delivery, what really is application lifecycle management, for pretty much my entire career. I did serve on the Eclipse Foundation, and I'm currently a board member for the new CD Foundation that's managed through the Linux organization. So I'm sort of keeping my, I guess, thumb on the heartbeat of what's going on in the CD world. And we're going to talk a little bit about that today because it's important to what we'll be going through as we transition over to a modern architecture and move away from our monolithic. So let's start there. Let's talk about where we've been so we can really understand where we're going. So right now, what most of us are doing when we write our software applications is we build a very large, what I would call static finished product. And I was hanging out with my niece who has 2 young kids, and they had put together this really cool dragon kind of Lego. And once it got done, and I noticed that there were very unique parts for that Lego set. They were not really interchangeable Legos like I used to have. And they got it done, and there was instructions, and it was very, very kind of puzzle-like. We got it done, and the kids, of course, wanted to play with it, and Mom said, no way, it took us too long to finish it, and she put it up on a shelf just to look at. And I thought to myself, that really describes monolithic software development. We have really big builds. Our releases are fairly heavy and for the most of us infrequent, even if we're attempting to do agile. We manage very large code repositories, and we're still in a dev test prod kind of waterfall approach. Agile has attempted to get us out of those habits, but the reality is that the way we compile our code, compile and link our code, is not agile. And the way we release it, it's not agile because we build it as a monolithic and we release it as a monolithic, even though the code itself may be incremental. So we might make small changes to the code, but the rest of the waterfall practices have sort of kept us from really achieving the promise of agile. So this got me thinking, it's like we're moving from more of a Legos mentality to more of a Transformers mentality, whereby we have the ability to have a continually transforming production environment. And with modern architecture, it gets us there in a way that Agile could not. We go from these big, heavy builds to small builds, small code bases, with very small repositories. Each microservice or code snippet or component has its own repository and build because it's independently deployed. And we're going to talk a little bit about what Service Mesh is doing to change how the deployment process actually looks in a modern architecture. Because everything that we do today in our continuous integration, continuous delivery lifecycle is being disrupted, every single piece of it. And we're going to go through some of that. I think the most important thing to understand, and what I've learned as I've worked with Kubernetes and customers who are building out a microservice architecture, is that configuration is really critical, and versioning is shifting. Where things are versioned and configured are shifting to runtime instead of build time. So if you think about what we do, currently in our monolithic process, when we compile code, what we do is the repository, the versioning of code is really connected to the compiling of code. In fact, as we grew into continuous integration, that's how it began. We started doing version control, and then with our version control, we would write a build script that would do a check out of everything out of our repository and compile it. And that's today, that's the way we're doing things. We don't just take one piece of code and pull it out. We generally do a full pull and then run the compile again. So what's occurring there is that we are not only compiling the objects, but we're linking the objects. So everything is done in terms of configuration management and versioning is done at build time. That's not the case in modern architecture. Most importantly to understand is that the linking step is really done through RESTful APIs at runtime. And how developers are managing this is they're trying to do it the way they did builds in the old days. They're trying to manage it with scripts. And they're trying to use the scripts to keep track of the microservices, Lambda functions, any code snippets, DDL that might be being pushed out in a small container into this modern architecture. They're trying to keep track of it in a script or in a spreadsheet, and it's really not super useful. In fact, we often hear customers telling us that, the release guy keeps these microservice relationships in his head. And to be quite honest, it is an impossibility to do that over time. So the versioning and configuration management functions are really shifting away from what we used to think of as builds and moving into the runtime space, which makes it a little more complex and a lot more critical because we're going to be managing many coordinated services, and being able to understand these relationships in this what we now oftentimes hear is called the Death Star will be essential in creating a successful platform for modern architecture and microservices. So let's think about how the lifecycle process is going to look. This is what we're seeing in these shops that are pushing microservices pretty heavily. First of all, your microservice has a lot less code in it. You don't have the concept of a C or a Java file that has hundreds of lines of code that developers edit at the same time, and so you manage branches and whatnot. That kind of goes away because you have small snippets of code. Basically, it's very, very few lines of code that one person would update and manage. Compiling it takes seconds, if at all, because some of these languages like JavaScript and PHP are interpreted, so you don't even have to compile it. And we don't link it because linking's done through APIs at runtime. And our build now, instead of creating a jar file or a big war file, even though you could have a container, a microservice that's a jar or war. It's just going to be a smaller one. The build step is really going to revolve around creating a container image. Products like Quay are repositories that help you store those. And when you use those, it creates a SHA number, and that SHA number is what is the beginning of our versioning, right? Because the repository now is what we're talking about is tracking the container image is more important than tracking the source, because that's what's being pushed across the life cycle, because that's what the build is creating. So your repositories will now store container images with SHA numbers, and those are going to be critical to understanding what you have running in your production clusters. And so this versioning and configuration management task starts to become more prevalent right there at runtime or right before you deploy. And we think now dependency management relating to application and service level dependencies versus a build with transitive libraries or transitive dependencies. So it's looking it looks very, very different from what we see today. So as you move down through this, as you do research and you start researching if you should be going into microservices, these are some of the things that I really suggest you ponder. First, think about what we just talked about, what the changes in versioning and configuration management looks like, because many of you have had unsung heroes who are build meisters or release engineers. We all know who we're talking about, who has managed those build scripts, even though Jenkins or some CI engine or CD engine might be executing it. There is a real human behind it who has written those build scripts and those release scripts to do that configuration management. And it's doable because it's one big monolithic application that can be tightly put in a package through these scripted processes and deployed out across your dev, test, and prod environments. So that is where the core of the configuration management occurs today. And that is going to go away, like big time go away. It won't be there at all. The second thing is, how are you going to track your services? Is that going to be done through a spreadsheet? Are you going to build a backend database to try to figure this out? How are you going to start tracking those services? And how will that change what the deployment looks like? And once you start tracking the services, how are you going to start managing the view of your application? Because now we don't have a physical application, we have a logical one. We can say that the physical pieces of the application are microservices living inside of containers that talk to each other, and that makes up our application. So this is another sort of change in the way we do things. It's coming everybody's direction as they move into this new really cool architecture. This is actually one of my favorite parts of Kubernetes and what we can do with it. So right now, what we see are most organizations using this staged Kubernetes approach, which looks very much like a waterfall environment. You create a cluster for your dev environment, you deploy your microservices there, and then you have a test cluster, you deploy them there, and you have a prod cluster and you deploy them there, very much like what we do with our physical server environments or even cloud images. But Service Mesh has the ability to change that. Now, it's not there yet, but this is what we're seeing come down the road. This is what folks are starting to think about and starting to work on. Why have 3 different clusters? Why not just have one? And when you move out a new version of a microservice, remember, in this world, the old microservice will still be out there. So you'll have version 6 of a microservice out there that version 10 of the application's using. When an update to that microservice is ready to go out, you're going to create version 7 of your microservice, and you'll have version 11 of your application. But 10 and 6 are still out there. So doing a rollback is real easy. But it has to do with, instead of redeploying, it has to do with routing. So Service Mesh will have the ability to route to different, what I like to call personas, individuals in dev, individuals in test, individuals in prod. And you may have your production environment be default, and you have Service Mesh, developers push a new microservice out there and they get that new feature, basically, kind of like a feature flag management, and they test it out, and when they're happy with it, it gets rerouted, or it gets routed to the folks in the testing area. So we're not doing deployments over and over and over. Now, if it's a database update, there may be some updates that have to be done in order to point to different database schemas, dev, test, or prod. But for the most part, much of the microservices, because they're independently deployed and they should not impact other pieces, have the ability to simply be routed. So this changes the way we have to do deployments all the time. Now, for a company like DeployHub, you'd think that would panic us, but it doesn't. It tells us that we're finally getting to a maturity level that deployments can start functioning more as the piece that tracks and configures things and versions than it does just pushing code out the door. Because that's in essence what we've always looked for. And in the old days, we talked about configuration management databases. Well, we actually now require one to manage these large service-based architectures. And that's where, at the deployment step, that's where it becomes critical. So when you don't do it, you get something that looks similar to this. I pulled this from the Netflix technology blog. So this is a Netflix Microsoft Map. And they often call, you hear different terms now for these very complex environments. Death stars, haunted graveyards is something we heard from the folks at Google, whereby you have certain clusters that they don't know if anybody's using them. So you have basically a cluster of microservices that you're not sure if anybody's actually consuming them, so don't bring them down because it might haunt you. Sometimes they're called Frankenstein clusters because they're just out there running and running and running, and you just don't know what to do with them. Now, if you're Google, you probably can afford to have a haunted graveyard, but if you're not Google and you're paying for that, you probably want to deprecate it. And part of this problem that we have to solve as a community is how to understand when you do deploy a new piece, a new version of a microservice, how long is it before you can deprecate the old one? How do you keep your environment cleaned up? What's going to be required for doing that? So let's talk a little bit about what actually is changing in a microservice. If it's a small bit of code, what potentially has impact to break things? So a code update generally is probably going to be the safest thing that we would do with a microservice. It's pretty small, and so it's going to be low risk, right, if there's a change to it. But potentially a change to one microservice could impact an application, and it could impact multiple applications. So if you update a microservice, who's consuming that microservice, and how do you let them know a new one's coming down the pipe or going to be deployed very soon? And should they upgrade to it? Let's say it's a security microservice and there's a vulnerability that it's replacing. We probably should let everybody know about it, but in many cases, the person who created that microservice and fixed that vulnerability has no idea who's consuming their microservice. So they have no way of updating the community to say, hey, I'm collaborating and we're sharing this piece, but I have no way of knowing who it is. Another thing that can change the way your microservice works is how it was installed. And tools like Helm and Red Hat operators, they are what deployment processes call to do the workflow activity that actually installs that microservice in the container. And inside that is a ton of variable settings that teach the microservice how to interact with the Kubernetes cluster. So if any of those variable settings are changed, that can have an impact on how the microservice acts, and it can have an impact on the performance of the application. So these are just some of the ways that a microservice can have an impact on a bigger application. And a reason why there needs to be a way to configure and manage the versions of the application over time, so you can understand what version of the application you're running and what it's consuming. And the most important part to remember here is that things don't get deprecated. In the monolithic world, when we put a new jar file out, we copy over the old one. That's not how microservices are done. You literally deploy a new cluster and you wait for or you deploy a new container and you wait for time to pass before you figure out if you can deprecate the previous versions. So you literally could have 4, 5, 6 different versions of a microservice running in your production environment. So, without solid CM and versioning, what happens? There is quite a bit of increased complexity and less visibility around microservices that has to be resolved. I pulled this article this quote from a woman that was quoted in SD Times in an article called Microservices More Isn't Always Better. I actually had some conversations with her. Her name was Alexandria Noonan, and we chatted over LinkedIn. And this is what she said in the article. She said, this is after they had implemented a microservice architecture. She says, what happened is we would release an update to a library, and then one service would use the new service. And now all of a sudden, all these other services were using an older version, and we had to try to keep track of which service was using what version of the library. It doesn't surprise me. This caused them to go back to monolithic. Now, it's true, this is a pretty new architecture. Companies are just now starting to dip their toe in the water and learn about how to manage containers, how to manage clusters. But if you're like Alexandra and they were really pushing it, I think this speaks to the need for maturity in the tooling around this new Kubernetes pipeline. And ultimately, that's what we're talking about, is that in order to be able to be successful in implementing this new type of architecture, we have to have the tooling to support it. And without the tooling, what we're going to do is we're going to fall back on our old habits, which basically is, let's write a script, let's try to have one or two people try to manage it. And in this world, we need to use our software. We need to use computers to manage it because it's going to be big. So just a word from our sponsor, who is me, and our product DeployHub. So DeployHub is I guess you could call it, it has traditional application release automation features in it, where it would compete with tools like a Zabbia or a Harness. But what we did is we set our sights on what were the problems that we were seeing with our customers who were looking down the road and around the corner and wanting to go into microservices and what needed to be done. We also said Agile should be acting in a more microservice-like fashion, where you have individual components that can be released and smaller jar files. So when we built DeployHub, we actually put a backend database and a versioning engine on it, and we began to understand how that versioning and configuration management becomes critical for creating the maps that you need to see what you've just put in production. We took a good portion of DeployHub and made it open source. So we have a project called the Artelius project, and it's all about how to do this versioning and configuration management and mapping of these services before they get deployed. Now, certainly you can take there are tools out there that you can have scan your Kubernetes and your clusters to figure out who is talking to each other. In a more of an application performance monitoring sort of a format. But what we're seeing that needs to be done is the ability to see the real impact and understand who's consuming what microservice, and allowing developers to have a location to share them, publish them, and collaborate around them. We also felt like when we launched DeployHub, we felt like it didn't need to be a really expensive product, because this is a tool that software development teams need to be using, and they don't often have a budget to buy a CIO level product. So we price it at about $2,500 per year per project. And the way it's structured is you can have as many microservices as you need. You can have as many deployments as you need. But microservices are collected in what we call an application, and that's what we charge it based on. In today's world, you might relate that to a Jenkins workflow. So how does it work? First, it allows you to catalog using what we call a domain-driven design. And if you are going down this road, learn about domain-driven design. You need a way to organize these microservices, otherwise you will lose them and it will be a failed attempt, because what's going to happen is the people on the 8th floor is not going to know that the people on the 4th floor just wrote this really cool reporting microservice, and they're going to go write it themselves. It creates a place for, once you create those domains, so you can define your domains any way you need to based on your functional areas of your organization. It allows developers to publish those microservices. And these are features of the open source. Once those microservices are published, other developers can find them in what we call the component hub. From that component hub, they can build out what their application looks like as their base version of the application. And over time, we integrate into the CI/CD process to say, hey, this microservice has got a new version, and we automatically create a new version of the application so that it's ready to be promoted forward if that's what the team wants to do. And of course, yes, we do shipping. And we do it without agents because we don't believe that sidecars and agents are appropriate for a highly scalable Kubernetes environment. So let's take an example. There's an example microservice application out in GitHub called the Hipster Store. It's pretty simple. It's a store that allows you to buy, kind of steampunk kind of clothing and old-fashioned cameras, and it's just kind of a fun little simple application. If you look on the right, you can see it's got a lot of lines there, and this is a single version of a really simple application. Now, when I did this, I got lazy and I didn't create a workflow for every single one of the lines that we just saw. I just took a handful of them. I took the security piece, I took the front end, took the product catalog and the payment service. There were many other pieces on there like ads and emails, but like I say, I got lazy and it got too complicated looking, so I just put a handful. If you think about how those services are going to be managed, they're going to be moving across the CI/CD process independently. And they get moved to the dev, test, and prod environments independently. So we no longer have a monolithic moving across, we have pieces and parts moving across. That's what we talk about when we talk about them being independently deployed. So what DeployHub does is it aggregates the whole, and it serves as that central place for configuring, sharing, and then deploying these microservices out to these dev, test, and prod clusters or personas. We've already done some testing with Service Mesh on pushing out to personas, and we're hoping that we can make sure that it's really commercialized over the course of the next 6 months, because we're beginning to hear people ask for that, to be able to just keep one giant cluster and route personas to those new features. If you look at what the map ends up looking like, and I show it this way so you get an idea. Here's again our hipster store, and it's super simple, and I've only taken 6 different microservices, and you can see how quickly we get some complication, which is why we end up with that massive Death Star or microservice map that I showed you from Netflix. And that's basically where we're all headed. Over time, we're going to all be looking like that Netflix microservices map. So how do you manage that map? That's really the question that we should be thinking about. And how do we keep track of the applications that those collections of microservices create? Because when we think about how we develop software, we're not thinking about a single microservice. We're thinking about an application, a teller application for a bank, an online store. So an application is not a single microservice. It still is a collection, and we're never going to lose that, because that's how we build out everything else on the early front end, like building new requirements, understanding what the customer needs. So we still have to have an understanding of what the application version is that the customer is working with, and we still have to have a roadmap for pushing out our applications. The difference will be is that we no longer have one big package. Instead, we have collections of microservices that our application consumes. And on that, I will say thank you for your time this morning and for listening to me drone on about microservices. Is something I'm pretty compassionate about. This is a super, super fun time to be in software. We haven't seen a change like this since probably moving from the mainframe to distributed environments and PCs, that really disrupted how we wrote software then. This is as big as a disruption. And as a community, we're going to have to really look at how to retool our continuous delivery pipeline, what I call a Kubernetes pipeline, to support the growth of this particular architecture. And on that, I'll open it up to questions.
All right, great. If you have a question for Tracy, please go ahead and use your GoToWebinar control panel and go ahead and submit your questions. While we're waiting for questions to come in, I do want to remind the audience that we are going to be doing the drawing for the $50 Amazon gift cards near the end of today's presentation. So please feel free to stick around. Tracy, while we're waiting, I kind of want to get a feel from you for the market in general. I mean, what do you see as far as kind of the general uptake in the market for this new kind of architecture? What are folks saying these days?
You mean what's driving it? If it's complicated, why go there?
Yeah.
So, I wrote this blog that described this. So for my entire career, I have heard discussions about fault tolerance and high availability. Fault tolerance, we have it on the production side, if you think about the ops side of the house, has been something that they have worked to achieve for the last 30 plus years. We've had ways of having, hot servers that we could swap out. We've always tried to achieve fault tolerance, but we've never really got there. And we've never really gotten to a place where we can scale fast. So these are two primary drivers, is the ability to have a truly 100% fault tolerant system. A microservice container dies, another one pops right back up like minions. And you can have a small piece of code that is needed during peak periods that can go out and replicate itself really, really fast, and then get rid of it, then go kill itself off. This is, in the data center world, this is phenomenal, because before we would have to have this massive farm of servers, just because between the hours of I don't know, 7:30 and 8 in the morning and 4:45 and 5:30, when everybody was leaving, logging on to their systems and logging off, we had a spike in usage. So we had to have this massive data center to support it. Well, that doesn't happen anymore. You have a tiny little piece of code that supports that function, and that can then spin up really, really quick, only for the period of time that it's needed, and then go away. Now, while this is important for data centers, because we've always tried to achieve that, and now we can, it's essential for AI and machine learning. I was an AI developer in the early 90s. I was an IBM consultant and worked on a product called Tears. And we could never achieve the level of pattern matching because we didn't have the processing power. It just wasn't there. There was a lot that we wanted to do. I was working with actuaries in the insurance area. There was quite a bit that we wanted to do. We wanted to be able to do massive pattern matching on, to be able to determine if you're 17 and you drive a Volkswagen bus, should you be charged more? And that's the truth and how those actuaries work. But maybe that's not the truth, right? Maybe it is the mom with 4 kids driving around that has more accidents. We couldn't see that. And the reason we couldn't see that is we couldn't run the pattern matching and do that kind of AI as quickly as needed. During that period of time, we were talking about neural nets, and Wall Street was trying to figure out how to really game the system. Did you ever see the movie Pi? Pi talked about this.
Yep.
But now with microservices and the way that Kubernetes sits on top of virtual images, we now can begin going down this road to real sci-fi. And AI and machine learning is driving it, as well as the ability to be truly fault tolerant and scalable. Because if you're a bean counter and you're looking at the cost of a data center, just to manage your Christmas holiday rush, and you're managing that data center 24 months or 12 months out of the year when you only need it for 1 month out of the year, you're going to push to move to microservices pretty quickly.
Okay. All right. Well, we have gotten a ton of questions in just in the time you were talking here. So let's go ahead and dive right on into them. The first one is, how does rollback work in this architecture?
Yeah, it's never really okay, so a rollback is a rerouting, right? Now, if you don't have service mesh, you basically you basically have a file that you're passing off to Kubernetes that describes what your application is consuming. So if you're doing a rollback, you basically are going to just to make it simple, republish that new file out to Kubernetes. And that new file is going to say this is now what the application, what microservices the application should be consuming. So that's a good question. These are the things you got to start thinking about is what is that? What does it look like? What's a roll forward, right? It is you're pushing out a new microservice and a new configuration file that says this is what the application is now consuming.
Okay.
Because the microservice gets pushed out before the application may be consuming it. You could have a microservice that's published and nobody's consuming it yet.
Okay, that makes sense. Yeah. Okay. All right. Great. So next question then, how long do I keep the non-prod deployments?
If you're talking about the clusters, dev, test, and prod kind of clusters, you don't. So if those would be the non-production deployments. I would deprecate a microservice as soon as possible. I would try to keep the dev and test environments as clean as you possibly can. But I don't think that's actually, it's not going to be realistic to be able to quickly deprecate, because if you have a microservice that several teams are using, you're going to have to make sure that nobody's using it before you deprecate it. And this was a question in the last webinar that I did. This is a common question: is how do you clean up those production environments? How do you clean up the dev test environments? If you have a cluster running in production and you don't know who's using it, it's going to become a Frankenstein cluster. You can bring it down. You know, in the old days, I used to manage. I did some networking as well. I've played in a lot of areas in the software business, and I would see these servers that have been running forever and it's never been brought down. And the only way I would know who's using it is I would turn the server off. But you really
Well, that's
can't
one
just.
way to find out, I
It's one
guess.
way to find it. It's exactly one way to find, because you get people running up to you really quickly. I did that at one point in one company I was working for, and nobody said a word. And I thought, well, you know, I'm not going to do anything with that server. I'm just going to let it sit there. And then come the end of the year, somebody came up and said, our server's not running. And I was like, what server is it? And they're like, I don't know. They had a piece of tape on the server with the name of it. And I went and found it, and it was one I had turned off 6 months earlier, but they only used it once a year.
That's too funny. Oh,
So,
God.
so unless you are starting to do configuration management before you deploy, you're going to have those Frankenstein clusters, or a server that's sitting in a corner running for 11 months when they only need it for 2 days out of the year, which is it's a waste in many ways.
All right. Okay, great. Here's a really good question. Can you please give a layman explanation what service mesh is?
Yes. So there's a couple of service mesh tools hitting the market. One's called Istio. Another one's called Linkerd. But the best way to describe what service mesh is it does the linking. It manages the routing and the request routing between the microservices. So think of it as a linker that manages routing. It's your new request router.
Okay. All right, great. Plenty of time for questions. If you have one for Tracy, go ahead and use your GoToWebinar control panel. Next question here, are backups done with microservers?
Not really. You don't really have the concepts of doing backups and backup and recovery. It's if you needed to do that, you would simply redeploy it. You'd pull your containers and you'd redeploy them
Mm-hmm.
into the
Okay.
clusters. Because remember, the clusters are not, they're not static, they're dynamic. So you might have a single container running in a cluster today, and then tomorrow you might have you might spin it up to have 150. Yes,
All right.
there's oftentimes there's a product called Rancher, and it helps. It's a great product to look at, and it's open source, and it helps you manage these Kubernetes environments. Well, why do you think they called it Rancher? The reason
Because it's
is
like herding cats, right?
no, it's like it's pets and cattle. In our
Right.
old days, we had pets. We had servers, like I just described, that had a piece of tape on it, had a name on it. I even had developers who'd want me to put a fan on their servers because they were afraid they were getting hot. So they were treated like pets. They were named and coddled. In Kubernetes, it's like cattle. We don't name them and we slaughter them. So
What
the
a fun
concept of
thing
a
to think
backup
about.
kind of goes away.
Yeah. Okay. All right, great. Let's see. Back to rollbacks. If I need to roll back 2 versions, I'm assuming I need to back out of the entire deployment or back out the entire deploy. Is that right?
If you are in a monolithic world, yes. In most cases, the way deployments are done is everything is deployed. So if you need to back out, you need to basically redeploy the previous safe version. So let's say you're on 10 and it's not working and you didn't get 9 tested, you need to get to 8. In a monolithic way, you basically redeploy everything. Now, you can't always do that because there's a database, if there's a database update. So in the DeployHub world for monolithic, and I'll answer it in 2 ways. For monolithic, what DeployHub does is it treats the database as a separate component, and it incorporates the database updates with the deployment. So it can do incremental processing of the database. So you can back the database out. But of course, if you had data out there and you back it out, you're going to lose that customer data. So that's not always an option. In the microservices world, you basically, everything's still out there. You never really get rid of it. You wouldn't probably deprecate the microservice you just released. You probably would simply republish your file that says to use a different microservice. So these concepts around like blue-green deployments and rolling deployments really change in the microservices world.
Hmm.
So the answer would be yes in the monolithic, but not so much in the microservices because you're really not undeploying anything. You might deprecate a microservice that you realized was bad after you republished your file that said don't use it. So that may be the way you would do it. But after you deprecate that, you're not really impacting anybody. And remember, a microservice gets deployed independently. So you as an application team might find out there's a new microservices out there. You publish your new file that says start using that microservice. And then you find out there was a bug. And instead of redeploying anything, you really just redeploy your file that says use the other microservice.
Hmm.
And you yourself probably wouldn't go out and deprecate that. You would probably call the person who wrote it and said, hey, that just broke the application. And they may deprecate it, and they may just push out a new cluster, a new container in a new cluster.
All right. I'm looking at the questions here. It looks like we have one more. So still plenty of time, guys. If you have a question, go ahead and send it on in. Next question, is it required to have separate databases per each microservice and why?
What was it? Which, could you say that again?
Sure. Is it required to have separate database per each microservices, and why?
No, it's not required to have a different database for each microservice. I guess you could do it that way, but it's not required.
Okay. All right,
So you
great.
can have a large database schema that more than one microservice is hitting against or updating.
Excellent. Okay, I've got less of a question and more of an observation on how our industry has evolved. This is from Kenneth. We seem to have lost key lessons learned in that transition from the mainframe to distributed systems. I was part of that change. For example, in the past 3 years, I was a member of a team building its first microservice-based application. When I raised the ideas of heartbeat messages, threads to reestablish network connections if they drop, clear, concise logging, etc., all I got was blank stares from everyone on the team born after 1990.
So I couldn't agree more. I worked a little bit in the mainframe environment when I first started my career before I jumped into the OS2 world. And what I learned there was that if we think about, we can go back on this conversation. If you know what Endeavor is, Endeavor was one of the first version control tools, and it had built into it it was basically a continuous delivery tool back in the day. And it still runs most of the government and most of everybody's governments and large banks. Endeavor still sits out there.
Hmm.
It had the ability to check. You could check code in, and upon a check-in, it would run a compile, so you didn't have to have your own compile JCL, and it would do the linking. So if there was any link edit step, it would complete that for you, and it would push things into your development environment so that you could test what you did. And if that worked okay and there was a quorum, everybody could push it forward. It would ship it to testing, and it would ship it to prod, and it would do it across LPARs. It did everything that we currently talk about and pat ourselves on the back about when it comes to continuous delivery. They did it a long time ago. And in fact, Endeavor stands for Environment for Dev and Ops. So it is the first DevOps tool.
That's pretty cool, actually. I
Yeah, it
didn't know
is.
about that.
When
So,
I was given the great opportunity to be able to go and be uh, questioned, I guess you could say, during the Obamacare, the Affordable Health Care Act debacle, where they were having so many problems and they couldn't get it rolled out.
mhm.
So I was summoned by CA to come go to Washington with them and talk about some of the problems that they were having in their configuration management stuff that they were doing. And I had two meetings. I had a meeting with what they call their distributed side, and I had a meeting with their mainframe side. With their mainframe side, there was one person, and he managed 400 different applications,
Oh my
and they
goodness.
weren't having really any issues. And they all agreed they were not having any issues. Endeavor was managing it all the processes were running. They could see exactly the problems. They could point out precisely where they were having communication issues with another program. They knew exactly what was going on. When we got to the distributed side, there was standing room only in this small conference room, and not everybody came, and they were managing 70 applications.
That's crazy.
So yes, we have lost a lot. It doesn't hurt to go back and look at lessons learned from our history,
Right.
because these are all the same problems. It's just different architectures. And that's why I decided to do this webinar. Is like, this conversation needs to begin now.
Mhm.
We have a configuration management and versioning problem in our sites. Let's consider where we're at. Let's look and learn from what we've done and apply those concepts forward. And we as a community tend to think that everything is new when it's not. It's just different. But the more things change and more things stay the same, it couldn't be more true than in the computer industry than anything else.
Yeah. Truer words were never spoken, that's for sure. Well, that looks like the end of the questions that we have. So I do want to thank everybody who did submit questions. There's still time though. If you have a last minute question you want to send it in, go ahead. We'll be here for a few more minutes. While we're waiting, actually, a couple things. Do want to remind the audience that today's event is being recorded. So if you miss any or all of it, or if you just want to listen to it again, that's totally cool. We like that. You will be able to do that. We're going to be sending out an email later on today that includes a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go there, find it. Just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. I did promise at the top of the hour that we would be doing a drawing for 3 $50 Amazon gift cards. So why don't we go ahead and do that now while we're waiting to see if any more questions come in. Our first winner for today's drawing of the 3 $50 Amazon gift cards is Balu Sulur, and I apologize if I mispronounce your name, but congratulations, Balu. Second winner is, let's see, Srinivasa Sama. Congratulations, Srinivasa. And our last winner is, here we go, Michelle Mello. Congratulations, Michelle. And thank you all for joining and being a part of today's webinar. Let's see, just double checking. Doesn't look like we've gotten any more questions in. So I do, again, do want to thank everybody who did submit questions, all really good ones, and fodder for, I'm sure, future webinars, hopefully. So Tracy, thanks so much for a great presentation. Really, really do appreciate it. Love to hear from you every time.
Thank you.
So great. And do also want to thank the audience for joining me today, giving you guys back 9 minutes in your day. I'm Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.